In this problem, we have 6 turns in a coil that's got an area of 5 square centimeters. You got to convert square centimeters to square meters. It's rotated in 5 seconds from position where it's perpendicular to Earth's magnetic field to one where it's parallel, right? And so if we were to look at the magnetic flux, right, it's going to be B. The magnetic field stays constant, the area stays constant, right? But now we've got this term due to the dot product of cosine, and the cosine, what are we going to have here? Well, it goes from 0 to pi over 2, or from pi over 2, right? The angle between the two goes from 0 to pi over 2 in this time period of 5 seconds, which I'm calling capital T, the time period over which we're doing this, right? So the total time period over which everything takes place is capital T. Any other time during that period is smaller t. And so this is the magnetic flux as a function of time as this loop is rotated, right? Well, the EMF is just minus n, right? And then this derivative, phi m dt, with respect to time. What we're asked for, however, is the average EMF, right? So we're asked for the average EMF, and which would be this, equals what, right? Well, generically, any function, right, the average of any function over any time t is the integral from 0 to t of that function as a function of time times dt. All right, so if we apply this to the electromotive force, or the EMF, right, 1 over t, that 1 over t is going to be our time, 5 seconds in this problem, 1 over t. So we know out of this integral we can go ahead and pull the minus n because those are constants, they don't change. And so we now have the integral from 0 to t of what? Of the derivative of the flux with respect to time times dt. Well, this one is really easy to evaluate because you've got the integral of the derivative and you just end up with the function minus n onto 1 over t. Okay, and so we're going to have the flux, I can't type a capital M apparently. All right, we're going to have the flux at time t minus the flux at time 0. All right. Well, the flux at time capital T is now 0 because we're at pi over 2 is our angle at that point. Cosine pi over 2 is 0. We get 0 out of the flux. And the flux at time 0 is just BA because the cosine is 1 at that point. We got this minus sign and that minus sign. They cancel out. And so we end up with NBA over T as the average EMF induced over that period of time. And there you go.